Crew successfully returned the Japanese carrier back into the payload bay. This was the Japanese Experiment Logistics Module Exposed Section, also known as the JLE, also known as the carrier. The SSRMS unberthed it from the JEF, the porch connected to the Kibo module, and handed it off to the SRMS, and the SRMS berthed it back in the payload bay. The SSRMS then went into a configuration that will allow the MT to translate. We're going to move the mobile transporter from worksite 8 to worksite 4. With today's JLE ops, that marked the end of very successful SSRMS operations for the docked mission. Everything went great as planned. All the SSRMS operators on board did a fantastic job, and so it was a milestone to complete the final SSRMS activity for today. Also today we completed the oxygen transfer from the orbiter over the space station. The final amount of the transfer will be determined in a little bit, but it's somewhere in the order of 46 pounds, plus or minus a few pounds. We'll get the final number later on today. Also today, the crew's going to prepare for EVA 5, the final EVA of the docked mission. They'll go through the procedure review. They're working on the tool configuration right now, and then they'll begin the physiological preparations, which we call camp out, and those will last through the night. EVA 5 is going to contain 4 main tasks. I'll briefly discuss what those are going to be. The first is what's called a Z1 patch panel reconfiguration for the control moment gyros. Basically what we're going to do here is redistribute which power channels our 4 control moment gyros are fed from. Currently, 2 of those control moment gyros are fed off the same power channel, so if we were to have a failure on that power channel, we would lose both of those CMGs, and that would put us in a very degraded and precarious position as far as non-propulsive attitude control of the space station. So we'll alleviate that risk by redistributing the power, by redoing these patch panel configurations on the Z1 truss segment. We're also going to go to the SPITM, the Special Purpose Dexterous Manipulator, also known as Dexter. There's some MLI that's not seated quite right, and we want to go make sure that that's properly laid down and in place. There's going to be some commissioning activities with Dexter later on this fall, and we'd like that MLI in the proper configuration for that. That'll be a very brief task. There's not much to it. And then Chris Cassidy and Tom Marshburn, the EV2 and EV1 respectively, are going to go down to the JEF, the porch, and they're going to install the vision equipment. These are television cameras that will be installed on the porch. They flew up in a launch configuration on the porch, and the crew's going to go down, take them out of the launch configuration, and put them in their permanent operational position. These should have been done on earlier EVAs, but we'll pick them up now on this EVA. And then the last task in the timeline is deploying a payload attach system. This is a mechanism on the outside of the space station that you can attach carriers and other structures to. This one is located on the S3 integrated truss segment. There's 4 of these attach mechanisms on S3, and currently none of them are deployed. This would be the first one, and it's located on S3 upper and outboard. And this site is needed for STS-129 ULF-3. We'll be positioning an external logistics carrier, or ELC, onto that. That ELC will be loaded with critical spare ORUs for the space station. So that's what's on tap for tomorrow's EVA. And you're also current on today's flight day activities. Both vehicles are performing very well. The crews are doing a great job, and the control teams around the world continue to do an excellent job in executing the mission. There was one issue with the ISS that we'll go over. Yesterday we had a failure of the carbon dioxide removal assembly. We call that CEDRA. We noticed some elevated temperatures, and we went ahead and issued commands to stop the CEDRA and turn some heaters off. The unit didn't respond to those commands, and eventually a circuit breaker that was feeding power to those heaters tripped. The circuit breaker is called a remote power controller, or RPC, but functionally you can think of it as a circuit breaker. We then had to start diagnosing the problem and troubleshooting and figure out a recovery plan. So I go through a couple times for you. The elevated temperatures started at GMT day 206, 1621. Yesterday afternoon, right before noon, Houston time. Roughly about 8.5 hours later, we were able to recover the seizure in what we call manual operations. And that's where we continue to operate today. To get us through the crew night, we did one extra lithium hydroxide, or LiO, change out on the shuttle side because the seizure wasn't operating yet at that point, and when we eventually were going to get it up and operating, we didn't know exactly what to expect or what its capabilities would be. But now that we've been running it since yesterday, we've restored pretty close to its nominal capability. We'll be able to tell in the next 24 hours or so how well we're doing. We'll continue to operate it in manual mode, and we are working on restoring it back to an auto operation. The difference between auto and manual is in auto, it does just what the name implies. It runs by itself with very little interaction from the ground. But with the circuit breaker tripped, the software won't run. It checks to make sure that there's power being supplied to these heaters, and when it sees that the circuit breaker is tripped, it's not going to operate. So we have to bypass that, and that's where we enter in manual modes. And from the ground, we send all the commands that the software would have sent. It's very command intensive. We brought in extra flight controllers specifically to do just that one job, operate the seizure. And as time goes on, we're getting more software updates that will ease the operation in the manual mode. And then also, we expect tonight to have a software delivery that will allow us to restore the automatic operations in the presence of that circuit breaker that failed open. We're still trying to determine exactly what the root cause of the problem was, but in the meantime, we're doing a great job managing the CO2. We're back right on to what the pre-flight predicts were, and we'll be able to complete the docked mission, and we'll have no issues in the stage following the docked mission either. We can continue operating in manual mode, and hopefully with the software fix we'll get overnight, we'll be back into the auto mode. Eventually we'll determine what the root cause is. We've got a couple ideas on where to look right now, and if we do need to replace some of the circuitry that we suspect, we do have spares, or a spare on board, and we can go ahead and replace that. We have a procedure to take care of that, but we're certainly not ready to go down that path yet.
Okay, thanks, Brian. We'll take questions here in Houston. We also have a bevy of reporters on the phone bridge, and we'll